So the idea is that today I would like to go through a larger example, and I'm going to use the format for the coming exams. So this is also a walkthrough of the exam format that you can expect. So I suppose that's good. So the exam, as it is planned, it's going to be a couple of assignments that you do on your own at home during the course of a week. So the dates aren't, I haven't looked at the dates yet, but it'll be 1 week around the time where the exam is scheduled to be. So at the end of the course somewhere there, you'll get the questions, and then you have 1 week to work on it and submit the answers. So that's the format of the exam. The tasks will be two main tasks with a couple of questions under each task. One of them is going to be about design patterns, and one of the tasks is going to be about design patterns, and the other task is going to be about the grasp patterns from the course book. So this is an example. So you invent a small system. That's the first thing that. So I'm going to ask you for one specific design pattern. I haven't decided which one yet. And I'm going to ask you to invent a small system where you think you can use this design pattern. And I want you to describe the system, how you intend to use the design pattern to solve one part of the system. It doesn't have to be the entire system, but one specific part of the system should be solved with the help of the design pattern that I ask of. Describe this briefly so I can understand what kind of system you're building. And then you create a class diagram with the attributes and methods and classes and everything that you need in order to first of all show that you know how the design pattern works, and then how to translate this design pattern into something that works for your particular problem. You can use, if you submit as a PDF, you can of course use any tool you want for creating UML diagrams, and if you don't have a UML tool available, then you can write the code for a UML diagram, and I will parse that instead. So once you've done that with the class diagram, I want you to describe this class diagram. How did you use the design pattern? Which classes were involved? Which methods are involved? And how, what roles and responsibilities do they have with respect to the design pattern and to the solution that you're building, the system that you're building. And then for the methods that are involved in the design pattern, you write pseudocode, or if you prefer, write it in Java or C++, for those methods where you are actually using the design pattern to create objects or to call and send events between objects and so on. So that's the design patterns tasks. And then for the grasp patterns, I'm going to give you two grasp patterns, and I want you to discuss them in relation to the design pattern that I was asking about in the first assignment. So, for example, in this case, we are looking at the observer pattern. I have those specified up here as variables. So, in what way is the observer pattern related to the grasp patterns information expert and controller? So how do they fit together? What mechanisms inside the observer pattern are using information expert or controller? And then you use the system that you used in the first task, the system that you invented, and describe how these two patterns, in this case information expert and controller, are used to assign responsibilities to the classes in your system. So how can you show that this method is in this class because of this grasp pattern, roughly? And that's roughly what I'm going to ask you to do for the exam. Since it's a home exam, you're welcome to use whatever books and internet resources you see fit. You may use each other as well, so you can discuss the exam with each other. That's okay. But when you do submit your solution, it should be unique to you. So I don't want to have two students submitting the same system, for example. It should be a unique system for each of you. And the answers, of course, to the questions and the discussion about the grass patterns and so on must be unique for you as well. You're welcome to reply in either Swedish or English. I'm guessing that you'll pick English, but you're welcome to use Swedish if you like to. Right, so that is the format of the exam. And that means that we can go in and start looking at the tasks and then work through this in today's lecture. So first of all, invent a small system. So I am going to use, let's see, a WebScraper, if you will. So I want to build a tool that will collect information from, for example, social media platforms, your Facebook page or some discussion forum or whatever. And if certain conditions are met, it'll take some actions on whatever it scraped and perhaps put that back into the web forum or whatever. But the actions can be configurable. So that's the system I want to be using. And I'm going to use the observer pattern in this. Since that was asked, I'm going to use the observer pattern so that I can collect information as a separate activity from taking action on them. So that I'm going to use the observer pattern to connect the collecting and the taking action parts of my system. A brief description of this. Something like that. And then we need a class diagram. Okay, and I'm going to use packages just to divide things up properly. So I'm going to have a package called Scraper. And I'm not going to go into that one because that's not relevant for the task in the for answering the question in the exam. So I'm just going to say that there is a package that scrapes information. I'm going to have a storage package. So whatever the scraper collects is put into a storage package. And this storage package is going to have a few classes in it. A content model, for lack of a better word. And it's going to have, let's see, of course, a method saying add content. Something like that. And maybe I can divide this content, this string, into smaller pieces that is more actionable. So just for the sake of it, I'm going to throw in one more class here. Like that, and the content model has a relation to the content atom. Like so. The scraper of course, sending information to the storage. I call that let's see how this looks like. Good. We have a scraper that inserts information into a storage module. And that's fine. Next step is we want to have the actions. Let's put them in a separate package as well, and let's have a separate package for the observer pattern as well. Observer pattern is nice in that sense that it has a nice clean interface that is the abstract interface, and we can put that into a separate package, and then we can use those classes in the rest of our solution. Now, the observer pattern, we have two classes in here. We have the observable, and we have the abstract interface or abstract class observer. Now, the observer class will only basically have one method. It's a notify method. We can probably say that it has a source, and usually we take a shortcut there and say that here's the content as well. Something like that. Technically, if you look at the observer pattern, they will only require that you pass on the observable. But you often see that you take the shortcut and saying that here's the new content as well. So otherwise, as the pattern is defined, you get pointed to the source, and then you go to the source and check what's new. And that means that the observable needs to keep track of what has been updated since the last time this observer checked in, which isn't really easy to do or necessary. So it's just as easy to say that I'm the source, here's the new content, here's why I'm calling you with the new update. So this adding the new content is that's a common shortcut. The observable class has a few methods. It's got an add observer method. And it's got, of course, the remove and so on, but those are more rarely used. So let's leave them for now. We have a notify method, and we have the list of already added observers. There you go. That's the observer pattern. So the add observer is called to add new observers to this list. They're just going to be appended to this list, and the notify method is going to run through this list, and for each element it finds in there, it's going to call the equivalent notify method in them. That's the observer pattern, codified into two nice little clauses. We should have a relationship between them as well, of course, which I haven't added yet. Okay, there we have them. We have the observable and we have the observer. Nicely specified. So let's go back to the actions package again. Move that down. Now, the actions I want to be able to do is that I want to be able to, if there is mentions of certain words, I want to collect statistics about these words have been mentioned. So counting how many times someone says Belgium, for example. So that's one class, and let's call it a statistics collector. Another thing we would like to do is that we would like to calculate things. If someone mentions that here's a formula, then we can do some nice calculations of that formula and throw in the answer. And the third thing I want to do is that if someone mentions a certain comic strip, for example, a certain number of the XKCD comics or whatever, it should throw in a link to that comic. So those are my 3 actions that I can take based on whatever contents I get. And in order to get the content, I'm going to inherit from the observer class. Like so. And this will mean that each of these collectors and calculators and searches and whatever are going to be addable to the observable here, so that the observable will know them as being observers. That's why I inherit them. So they are observers now, and they can pretend to be observers, and that means that the observable can deal with them. This means that they will have the notify method implemented. We can, I suppose, put that in. Like so, and the math calculates the same thing. And the comic searcher. This is sort of redundant to say this like this. Since the observer class is abstract, there's no chance that these classes do not implement the notify method, because if they didn't implement the notify method, they would also be abstract. But sometimes, in order to be clear and explicit, you would copy that these methods are the ones that are implemented in this class. So in order to be clear, that's something you can do. And as you see now, I have connected my actions, and the entire actions package is now connected to this part of the observer pattern. All I need to do now is to connect the observable to my storage, so that the content model inherits from the observable. There you go. Content model is observable. This means that it has the methods add observer and the notify, and it's got the list of observers as well. So what will happen now is that when the scraper inserts something, it'll use the add content method. The add content method will break things down into the different atoms, and it will call the notify method. The notify method will run through the list of observers, and for each of them it'll call the corresponding notify method, which will be either one of the statistics collector, math calculator, or the comic search and notify methods. They will look at the new content. Each of them will decide, is this something that is relevant to me? If it's a math formula, yeah, sure, this is me. If it's a comic strip, then this one will say that, yeah, this is me. And the others will simply ignore it. So if it's not their job, they will just return. If they see that they can do something about it, they will do something about it. And um, that's about it. So this is how I'm using the observer pattern. What was the next question? So we are going to describe how we've used it. Um, so basically describe the class diagram so that when I'm reading it, when I'm marking your exam, I can look at this description. I can see that this is how you intend to, this is the rationale behind your design. And the description of how the pattern is being used. So we have a couple of packages. Let's describe them. Scrapers collect information. Uh, that's what the scrapers do. The storage, what does that do? That stores information. I have the chat window over there, so I can't see if I spelled things correctly, but I suppose you'll yell if I mangle the words too badly. Next package simply reacts to new contents. And then the observer pattern. So this is the generic classes that are used to build up an observer pattern. And I might say something about the observer how the observer pattern is used. Uh, so the first part that happens is when I add new content, it will call the notify method, and this method will run through the list of observers. And they will then decide whether to do something about it or not. So brief description. You can probably polish this description a bit more to make sure that it's clear how you're using the design pattern and a bit more about roles and responsibilities and so on. But this is a good start anyway. I'm double checking my notes here on the side if you're wondering what I'm doing. Right, and the pseudocode now. We would like to do something for the add contents method. Or actually, we should first describe the design pattern methods, which would mean that we do the add observer method. So we would do the notify method. And we would do the observer method. But that one is abstract, so we will take one of the concrete subclasses. Put the comics archer, for example. Those are the methods that are somewhat involved in the observer pattern, but in order to trigger the notify method, we also need to do the add contents method here. So those are the ones that we really need to go through. I'm going to call it Java. I don't think it'll be, but we can, just to get some form of syntax highlighting here. The add observer is simply going to be a method. Actually, let's do it in C++. This was the signature, right? And the only thing we're going to do is that we're going to add this to my observers, the list of observers that we had. Right, the notify method. No parameters there because we are going to notify everyone. And I'm not sure whether you can do this in C++ yet, but I'm going to pretend like you can do it because Lambda functions are so much nicer to do this in. And where does it get the new contents from? That we might add something. This is probably the reason why you would not put the new content into the design pattern as it is, because that would mean that the observer and observable classes need to know that what kind of contents you have. So let's just make a comment about that. You don't get away with doing this in the exam though. I can do that because I'm the teacher. This will call the notify methods in each of the observers, so we can have something here. And what are we going to do with this? Well, we're going to, let's just split up the string and see if I can find any of my keywords there. Or actually just look at the first word. Is this something that I should do something about? And if it's in my list, then do something about it. So this is, so far what we're doing is that we're describing in some form of code that we know how the observer pattern works, and that's about it. And that's important because otherwise it's easy to know the abstracts of a design pattern, but this will show me that you're also able to translate the abstract design pattern into something that will work in your particular case. So the add content method, what are we going to do in this one? Well, we are going to store, create atoms, we said. And let's throw this into some sort of storage. And let's notify everyone. So this is just what we were supposed to do anyway with the content model. We are creating atoms as we go of the data that we get, and then we store it somehow. And the next part is the connection of the observer pattern. And that's it, really. We have now all the methods here so that we have, when new content arrives in the add content method, we store it and we tell whoever's interested that we have new content. That will call this method, which will run through the list of observers, and it will call the notify method on each of them, saying that I'm me, here's the new content that's happened since last time you checked in. They will get notified, like the comic searcher, and there'll be an equivalent method in all of the other subclasses there as well. They will have this notify method, and they will do whatever they like. In this case, I just took the first word that I got in the string and I matched it against whatever keywords that I had that were mine, if you will. And there's no requirement that you should actually do implementable stuff, and it shouldn't be runnable based on the exam. So that's why you can get away with saying do relevant stuff here. You've shown that you've understood how the design pattern works and how you can take actions when it's your turn to take action, but you don't have to actually take the action. So a comment here saying that this is where we do the relevant stuff, that's okay. And the last method that we need in order to get the observer pattern complete is the add observer. So we just to show somehow that there is a mechanism for adding new observers to the design pattern. So I'm going to pause a bit here, and I'm going to back up to the class diagram that we had, because it's a good point to say something about how the observer pattern works now. The reason why we want to have this in a separate package, or why I did that, is to show you that this package can be built in Java. It's built into the standard libraries even. So the observable class doesn't need to know anything about your system doesn't have to be aware in any way, shape, or form about what you're actually going to do with it. All it knows of the world is that it's got a list of observers. That means that it's very, these two can be tightly connected, but they are very loosely connected to the rest of the world. And then when you start building your system, you extend the observer with whatever behavior you need. And that means that the observer pattern doesn't need to know anything about the actions that you take. You extend this, and this is your application. This is whatever is specific for your application. As long as you inherit the observer interface, or the abstract class in this case, as long as you inherit from that one, that is sufficient for the observable to understand that how to deal with you. So you're completely disconnected from the observer pattern and the rest of the system by using this. So the inheritance mechanism is very loose in this sense that you can inherit from anywhere, and you can pretend to be the base class, and none will be the wiser for it. Same-ish way with the storage and the observer pattern over here. We inherit, which means that we don't have to be known to the observer pattern. We really didn't actually need to inherit here. We could aggregate an observable as well. In Java, it's even recommended that we do not inherit, because that wastes our one chance at inheritance, since you don't have multiple inheritance in Java. So I would probably do an aggregate there instead. But in order to show how the observer pattern is being used, because I want to have these methods, I want to have access to these methods somehow, and by inheriting, I get them as part of my interface, which is good, because then someone can add observers when they create the system. If I aggregate things, then I need to duplicate these methods into my main interface, and just pass it along to my aggregate. So it's slightly more cumbersome, but so that's why I would normally say that I inherit, because I inherit the behavior. But there are nicer ways of doing it, especially when you're coding Java, when you can't inherit behavior from more than one place. But using inheritance, same thing here, we get disconnected from the observer pattern. The observer pattern can be part of something bigger where I might not even have access to the source code, and I can still use it in this way. Note that there is no connection at all now between the storage module and the actions module. The only link between them is indirectly via the observer pattern. And that is the mechanism that I'm after. I want to have these loosely connected parts of the system. The storage part doesn't know anything about what happens once it calls the notify method. It doesn't know, it doesn't care what actions are taken or if any actions are taken. All it knows is that when it gets new content, it's going to call the notify method and saying that I have something new here. Do with it whatever you please. So there is no connection between the storage and actions unit, and that is part of the beauty of the observer pattern here as well, is that we loosely connect our application via this indirection that the observer pattern is. So that was a few words about the observer pattern and half the exam solved for you, if the exam had been about the observer pattern. I suggest we take a break now, resume at 10 minutes past, and then we'll go through the discussion of grass patterns, which was, I think, the next task. So we've done these four, and the next bit is to describe the grass patterns and how they are used in the context of this the system. But let's do that after the break. I'm pausing the recording now. So the next part is to discuss two grasp patterns in relation to the main design pattern that you've built your solution to. And I am going to use information expert and I'm going to use controller. And I am maybe I'll talk first and then I'll write later, so you can follow along my reasoning first, rather than just watching me type. What we have the observer and observables. So the observable is an information expert on whom to call when there is something to tell, when I call the notify method. But it is also a controller that delegates the responsibility of doing something based on that to the observers. The subclasses of the observer, they are information experts on what to do when they get a call. So they're the domain experts in that sense. And that's the graph patterns in relation to the design patterns. Let's write this down then. Let's say they were information experts. When a notify method is called, they are information experts on whom to call. It's a controller that delegates responsibility of acting on new information. It delegates this responsibility to each of the observers. And in that sense, it gives an opportunity to each observer to do whatever they want. So that's one side of the observer pattern. The other side was the subclasses to the observer. So whenever they get a call via the notify method, they are information experts on whether they should take any action and in what way they should take action. So next question, use the system from task 1 and describe how I've used information expert and controller to assign responsibilities. That's the last question on this exam then. And then it's just a matter of going through each of the classes that I have and discuss in what way they are using these two graph patterns. So the content model, let's start there. It's an information expert on how to store new content. That's part of the domain model in some sense, that it knows when and how to store the data it gets. And the other side is that it's also an information expert on the structure or the process of the system, in that sense that it knows when to call the observers via the notify method. Content model is also via the observable class. It's an information expert on what observers are available. Um, that's part of the same discussion as we had before. So it's also a controller in that sense. What else? And all of the subclasses here of the observer. HD, right? Yeah. Um, um, and that is the I don't have to write the same thing for all three of these classes. I'm using all of the subclasses here and using one as an example. That there are keywords that trigger it in the new content, and it's an information expert on what those keywords are, and it's an information expert on what to do when those keywords are triggered. Mind you, I'm not going to write this, but just for the sake of reasoning with you, it could also then be a controller. So for example, the comic searcher, based on the keywords, it should probably go find a specific comic, maybe a specific comic page, and then interface with it in order to search for a comic that mentions certain keywords, and then it should download that comics, and it should post a link to this comics somewhere. That's quite a lot to do. So maybe it is a controller in its own right in order to do all of these tasks. But that's not part of the solution as we have written it yet. Let's not dig deeper into that rabbit hole. Is there anything else? Well, the content atom, let's mention that one as well, just to be complete. The content atom is an information expert on one particular piece of information, and that's about it. And that is how I'm using these two particular graphs patterns, information expert, in order to allocate who should do what, who should know what action to take on a piece of information, well, or new piece of contents. Well, it's the actions here, one of these subclasses, or maybe I need to add another one if it's a new action that I need to take. So that's good. I've got information experts over here. Who is information expert on new data and new contents and what to do with it? Well, it's the content model over here. So whenever I have any questions about dealing with the contents, it should be over here. And who is the information expert on binding the things together and notifying what parts of the system should be notified when something happens and so on? Well, it's in the observer pattern. So those are my information experts. Controller is here in order to direct the flow. A controller could be over here as well, as I said, in order to aggregate a larger workflow. And that's about it. This is, with a few embellishments, writing a bit more prose, extending the text a bit. That's more or less what you need to do in order to answer this exam. Not too hard, is it? Are there any questions on this? I'm going to stop the recording so that you're free to